Once again, welcome all to the third session of Web3 Bootcamp by Kerala TPG. This session will be taken by Darshana. So, Darshana, you may start the session. Ashwin, Darshana, please do allow Darshana to unmute.
Hello, am I audible?
Yeah, you are.
Okay. I can't switch on my video, so I just assumed it wasn't necessary. Is it necessary?
Uh, yeah,
Yeah, I'll rectify that.
Yeah, okay, sure.
Please try now.
Yeah, can you guys see me?
Yeah, we can.
Yeah.
Cool. I think this should work, right? Okay, I will try to share my screen. I can't share my screen.
Try now. Yeah, now we can.
Yeah, I'm on. I hope my screen is visible. Okay, sure. Just let me know if my screen is visible.
Yeah, it's visible.
Okay, and I am audible.
Yeah.
Okay. Cool. Thank you, Harshal, for introducing me and giving me the opportunity to continue another week in the Solidity Bootcamp. And hi, everyone. I hope you guys remember me from last week's session, where I went through week 2 of the Solidity Bootcamp. I went over the basics of Solidity programming language, and in this week 3 of Solidity Bootcamp, I will be covering some topics on intermediate Solidity. So I hope you guys have like some basic experience in week 2 Solidity, like where you guys have gone through the previous week's session. And if not, you guys can just stop me in between, ask any doubts, or I'll be happy to help anytime, even in between the session. You guys can just put it down in chat or something. So I think I'll just get started. Cool. So welcome to week 3 of the Solidity Bootcamp, which is about intermediate solidity. And the objectives of this week is to go over data locations. So in data locations, we will be going over what are the different types of data locations and how to recognize when to use these and how to use data locations such that you are minimizing gas cost and optimizing data storage. So if you guys would have attended the previous session, I would have gone over different ways where I already mentioned how to write Solidity code in smart contracts such that you can optimize storage and also account for lesser gas fees. So that is one thing. And then we will go over the importance of events in smart contract, like what exactly events are and how to define and emit them. And about error handling, we will see how to like handle errors and exceptions in Solidity, just like any other programming language. We need to deal with error handling over here. And then in interfaces, we will go over how interfaces are used as a mechanism for contracts interaction. So interfaces are basically how you interact with different smart contracts. And inheritance, how you will be exploring different parent and child smart contracts and how the inheritance is passed on between them. And then in cross-contract calls, you will check how interactions are happening between different contracts. So, and how you can determine different use cases and also best practices whenever you are, implementing different cross-contract calls. And then finally, you will learn how to delegate the call and call functionality. So this is what I hope to go through in this presentation. But before we go forward, it will be very helpful if you want to review the previous week's session, because I think in case people have not attended it, I'll just go over a quick 5-minute review because otherwise it will be kind of hard. So previous week we went over introduction to Solidity. We went over what exactly Solidity is. And Solidity, as we know, it's a high-level programming language. It's used to code smart contracts that are used in blockchains. And we talked about what a smart contract is, how its layout is, how the various terms are used, and how we have different variables, functions, constructors, and the first line, which basically starts with version flag now. And then we went over what Remix editor is. Like Remix is where we write, deploy, and test smart contracts online. It's like an online IDE for blockchain development. Now, we also went over variables and Solidity. Variables, it's the same how is in different programming languages. You store and manage data. Again, there are state variables, there are local variables, and how you can define different types of variables. You can declare them in the starting of the smart contract. And then there are different data types in Solidity. Whenever you define a variable, you can use different data types. And these are the four main primitive data types that we've seen: uint, int, boolean, and address. And then we went over certain terms that are generally used in blockchain. Like you go to any conference, just listen to any workshop, you'll just hear these terms everywhere. So we talked about constants, ether, and gas. And talking about ether, we went over different units of ether and gas. We also mentioned why gas is important and how we need to reduce the gas fees throughout, like whenever we are writing code for smart contract. And then I also give two different exercises where you can just, write a simple contract using the stuff that I mentioned. These are different ether values. And now we went over arrays and structs in Solidity, how you're going to write certain things in smart contracts. So like we mentioned that you write code in smart contract, but like what, structures to use, what arrays to use, we went over them. And then how to map different structs and map different arrays. And we also went over conditional and looping statements. So this we did. Now I will go over week 3. I just went through this because this is quite important for what we're going to in this week, right? So now let's come to data locations in Solidity. So in Solidity, there are different data locations, and these determine where the variables are stored and how they can be accessed. So we went over variables. Now we're going to store them in different data locations. So we're going to see three main different data locations. So the first one is storage. Storage is when the data is stored in the Ethereum blockchain, and there is like persistent remain between function calls and transactions. So these are directly stored in the blockchain, and they are also used for state variables and complex types. Now, whenever you are going to retrieve anything that is there from the blockchain directly, you're going to almost always use a lot of gas. So this type of data location uses it's expensive in terms of gas costs. Now coming to memory, coming to the second data location, memory. Now this is a temporary data storage during function execution. Now we have gone through functions and structs and arrays. Whenever we write functions in smart contract, we can allocate data in memory just for the function. And once the function execution is done, the memory that we are allotted for the variable is now cleared. So basically, this memory data location is used for function parameters, local variables, and dynamically sized arrays. So that once you remove the information or data from the array, the size reduces and you don't waste a lot of gas cost in defining or implementing them. And the third one is call data location. Now here, it's an immutable data that is part of the transaction input. So basically, you cannot modify it. Like it's there from the beginning itself. You can only access it. Like how in storage and memory, you can access and even modify them by, writing certain lines of code. But for call data, you cannot really modify that. We will see over later how you cannot modify and how you can only call that data. So it's basically only used for function arguments whenever you call external functions. So you have functions that call like certain variables or certain constants from outside the function. So that is where you use for call data allocation. And as we can as we can easily see, call data will have like minimal gas cost because there is no state change also allowed. Because it's only used for this one thing where you can call data, you cannot really modify it. Gas costs are very less, but for storage and all, it uses a lot of. It's very expensive in terms of gas cost. So we have this example over here. I can also go to it in the remix folder, I think. So in this data location dot solve, this is just an example that I have over here. So in this example, you can see that state variable is a state variable that is stored in storage. You can see here, state variable. You are basically storing it directly in the blockchain. So it's initialized in the constructor itself. You can see its initialization here, and it can be modified using this function. So this is a state variable that is stored in storage location. Now you have local var. This is another variable, local variable here that is stored in memory within the read from memory function. So this local var is only there within this function, right? So this is another type of location value. And then you have add to call data function. And this demonstrates the use of call data for function arguments. So call data is read only and you cannot modify any function. So you can see that it returns this underscore A to underscore B. So it returns these values that you get from outside the function. You are not declaring it anywhere. You're not initializing it anywhere. So you just like accessing it from here. So that is call data. Call data, data location. And now, so that is the first part of how we are going to store data in different data locations on Solidity. Now we'll come to events. Now, why exactly are events even there in Solidity? Because we don't usually have stuff like events in any other programming language, right? So the importance of events in Solidity is basically because there are three main reasons why we have events in Solidity. So the first one is off-chain communication. So you in smart contracts, whenever you use smart contracts in different Web3 applications, you're not using it only within the blockchain. You're using it to communicate with external applications. Even and most generally, these will be front ends. You will be, accessing external links. You'll be retrieving data from there. So um, in these scenarios and in these DApps are basically Web3 apps. They can listen to events and react to changes in the blockchain state. This is how off-chain communication events are important. And now in auditing and transparency, events acts as a historical record of important contract actions. So they allow anyone to verify and audit that this contract has done this and so thing. And so this is why we generally use blockchain, right? One of the main, use cases of blockchain and Web3 apps is that we are using it because there is decentralization, which means basically there is trust, there is transparency. If you want to verify any information from outside or anyone outside, if you want to verify any information, you need to have the transparent stuff. So these events help in automatically auditing these information whenever certain calls are done. So this is one important reason why events are generally used. And then decentralized oracles. So events are used as a mechanism for off-chain oracles to relay information to smart contracts. For example, an event can signal that a particular condition has been met in the real world. So now both of these words are quite new for everyone. So I'll just explain what oracles mean. Oracles are data feeds that bring data from off the blockchain data sources and put it on the blockchain, the smart contracts to use. So again, we are going through stuff that we will be dealing with whenever we are writing a real world blockchain app. So in these real world blockchain apps, you will be dealing with information. You'll be using information in the app itself that is, retrieved from outside the blockchain. You will be using it from outside. So oracles are these certain data feeds. They're called data feeds that they bring data from outside to the blockchain. And this is necessary because smart contracts running on Ethereum cannot access information stored outside the blockchain network. So again, when oracles are used, events help in auditing these, information that is used by oracles as well. Now, now that we know what events are, we can see how to define and emit events. So just like I mentioned, events are, these specific keywords that are there only in Solidity. You also see that emit is something that you haven't usually done with any function or anything before in any programming language. So this is again another type of function that you can only do with events. So in Solidity, you define events within a contract using the event keyword. We have seen keywords before. We have seen how we define functions using function, struct, etc. So we define an event using the event keyword. And here's the syntax. You see event space event name, which is the name of the event. And in bracket, you give in certain parameters. You give in the address, and then this is another keyword that is used for an event. Basically, indexed means that when you mark a parameter as indexed, it allows for efficient filtering of events based on that parameter when querying the blockchain. So let's say you have a lot of data within the blockchain. You usually have users that are, logged in the blockchain. There are different data, like there's a lot of information that's stored in the blockchain. Now, when you are retrieving information from them by using an event, using an event, you don't want all information. So let's say you have a car. There are different, cars data that are available in the blockchain. Let's say you have a Maruti and it's black, and so and so number, and that is there, and so specifications. Now you also have another Honda. You have a Mercedes. You have Benz, and you again have different colors. The Honda is yellow. The Mercedes is red. There are different stuff. Now you don't. Let's say you're creating an event. You don't want all the information from all the cars. You only want, let's say you want the Honda and you want the color. You don't want the specifications. You don't want anything. You just want certain stuff. So that's where indexed come into use. It's like how you query certain data from, a database. I'm using it for Web2 programming language stuff. So this is where indexed is used. Now, this is how you emit the event. So you emit, which is again the keyword that is used to emit the event, and event name. Parameters, you give the sender, the value, and then like a message telling what event is being done. So let's say in the cards example that I gave, let's say you are telling the buyer different types of cars. So you can give the event different types of cars like that. You're giving that sort of event. Now, yeah, I think this example should also be there. Okay, if not, we can just do in this itself. So in this contract, this is an example to tell you how events and logging is done in Solidity. You can see that we define an event payment received to log the payment events. So you have the smart contract payment logger. You define an event called payment receipt. In this, you log the payment events, the payer address, the address of the payer, and the amount these are the indexed parameters. So this is how you use it in a smart contract. Now the make payment, this is a function called make payment. It allows the users to make payment. So whenever a payment is received, it emits the payment received event with the sender's address and the payment amount. So let's say a user from outside is trying to pay using this event. Like you have a UI, and this user from outside, he goes into the blockchain, he interacts with the UI, and then he tries to pay, let's say, 3 ETH or something like that. He tries to pay that amount. What he basically does is, whenever he clicks that button, you will have some button in the UI to, let's say, make payment or something. When he clicks that button, this will trigger the blockchain to execute the event that is that using the function. This function called make payment. This is how you code whenever you code real life blockchain apps. So uh, this will check. So this line over here, it will check the value that the user is giving to be greater than 0, because you don't want the payment or something to be added unnecessarily. Once there is like 1 ETH or 2 ETH, this if, like this line will be checked whether this value is being satisfied or not. Then it will show, okay, payment must be greater than 0. If it's not shown, I'm sorry, if it's not greater than 0, then it will give this sort of information to the user. And if it is satisfied, then this emit event, this event is emitted, basically the payment received event that we have done before. And what it basically does is it retrieves the information mentioning what is the sender. We only need the sender and we only need the value. We don't need any other information related to the field. So this is how you use events, and you log only certain events that are necessary in Solidity. So this is one small example how you can do that. Right. So now that you can do, now that you have known how to code events and how to log the information related to these events, you need to know how
Excuse me.
to.
I have one doubt. What is
Yeah.
decentralized oracles? What is oracle?
Right.
That's
I meant,
events and logging. Yeah.
I went to that did I go through here, right?
Yeah.
Yeah. So I haven't mentioned oracles over here, but like I mentioned before, oracles. So like I said, like when you code the app, you code any Web3 app, what happens is you sometimes need information from outside. I'm sorry, someone trying to talk. Okay. Okay, I will try to explain. I think it's someone just unmuted. But oracles, I haven't shown an example over here, but these are, high-end examples where, let's say you're trying to code a app, you need information from outside. Like, let's say Google itself. Let's say you want to, Google something and you want to get it from a website from outside. So oracles help in doing that. They are used in real life data Web3 apps where you can actually get data from the website. You can't do that using any blockchain. You have inside a blockchain, you can only get information from inside the blockchain. If you have mentioned it before, if you have defined a data type or a function or variable before, you can only get it from there. But oracles, they help in getting it from outside the blockchain.
Oh, okay.
Yeah.
Okay, thank you.
Right. Sure. Okay. No, that is a very good question because I haven't mentioned oracles over here. So maybe, right. So now that we have seen how, we how we can use events and how we can log certain messages in the blockchain, we can go over how to handle errors and handle error handling in Solidity. So just like any other programming language, whenever you write certain functions or events here, you will definitely encounter something where you will be like error 404. You can't really, use the website. People would have seen that whenever you try to visit the website. But we don't really want the whole app to, freeze or stop just over there. We don't want to, we don't want the process to stop just because they have encountered an error. So we need to handle errors and exceptions in Solidity the proper way, now that we have seen how to use events properly. So error handling, it's basically, like I've mentioned, it's useful to ensure secure and graceful contract execution, and it helps prevent unexpected behavior and vulnerabilities within smart contracts. And there are basically three primary functions that are used for error management. These are require, assert, and revert. So require, basically it means you use to validate conditions and revert the transaction if the condition is not met. Commonly used for input validation. So here you can see how, we've used this line called require, message dot value is greater than 0. So this line that is, beneath that, this will only happen if the message dot value is greater than 0. If the user gives a value that is more than 0. So this is how error is handled, and like exceptions are handled. Because let's say you don't have this line, and there is payment received in anything, like the value is locked, even when someone is when a bot tries to click on the button multiple times or something like that happens, the app is going to crash because you're going to overload the data in a very small amount of time. So statements like this. So this is the first statement that is generally used in error handling. So the second one is assert. And what assert basically does is used to check for conditions that should never be false. If an assertion fails, it indicates a critical error in the contract and the transaction is reverted. This is again same as required, but it's used in certain scenarios where it is very mandatory for the condition to be true. Like let's say this is the first payment process. Let's say a user has done, has started the payment process, has initiated it, has done a few things, and then in the end, he has not mentioned the payment, or the payment is wrong, the amount is varying or something. That time we use the assert function so that, like it will deal with some, it will mention that there is some critical error that is there, and then, like we take the necessary steps. It's more serious than assert. Require, I'm sorry. And then the last one is revert. And what it basically does is it allows you to provide a custom error message and then revert the transaction with that message. So it's useful for providing specific error details. So there will be cases where you will need to give, multiple statements for multiple scenarios. It's how you, write any switch code. Like you give a data, and then if this data is 0, you'll be like, no, it needs to be greater than 0. And then let's say it gives 1 or something, like, no, it needs to be less than 1. And then something in between, you need to give certain types of error details. This is how you do it using revert. Now, maybe there is an example. I've used examples for every single thing that I've mentioned because it'll, help you to understand what I say. So here we have defined this new event called payment received to log the payment events. So this make payment function here, this make payment function, it allows the users to make payments, but it requires that the payment amount is greater than 0 using require. Same as what we have done before. If the requirement is not met, the transaction reverts with the provided error message that the payment amount must be greater than 0. Now there is another function called withdraw, which allows the owner to withdraw funds. But what it does is it checks for conditions such as the withdrawal amount is greater than 0 and the contract has sufficient balance. So it requires that this is there, and it requires that the amount is greater than 0, because if not, it will show withdrawal amount must be greater than 0. And it also checks if the amount that you're withdrawing is less than the balance that you have in your wallet. Or if not, it will give this error that there is insufficient balance for withdrawal. And it checks if the now here we can use revert to provide this custom error message where either one of these things is like, so I'm sorry, I think I misread the function over here. So this require function, require statement keyword takes care of both of these parts. But if the person who is asking for withdrawing cash, he's not even the owner of the account that he's trying to get cash from, then you can see that this is a critical message and it shows only the owner can withdraw funds. So this is why you use revert function. Now there is another function called critical error. It uses assert to intentionally trigger a critical error. If this function is called, the contract will revert due to the failed assertion. So basically what it does is it checks for if there is any critical error, and if not, it if there is a critical error, it shows that there is a critical error and the whole transaction stops right over there because of the failed assertion. This is how you use assert statements over here. This is just an example. Once you code a fully functioning application, you'll be using more of these keywords and more of error handling and exception in every single page and transaction that's going to be done. Now we will go over another important interfaces in Solidity. We are going to understand what interfaces are and how to create and implement interfaces. So in Solidity, I'll just go over an introduction to interfaces. An interface is a way to define a contract's API without providing the actual implementation. So interfaces are used to control the interaction between contracts and enable interoperability among contracts and other dApps. Now, interfaces specify the functions that the contract should implement, thus making it possible for different contracts to work together without knowing the internal details. So you can have different smart contracts, different apps, and just because you're using them together, it doesn't mean you are going to, store data for both of these apps in the same space. Or you don't need you only need the data that needs to be given to be shared to the other, smart contract or function that you're dealing with. So you can specify these functions so that extra data is not, you are not, compromising the privacy of the user, basically. So creating and implementing interfaces, basically it involves defining the function signatures that the other contracts should implement. Like I mentioned, you're specifying the functions that needs to be given to the other contract. And these functions have no body. They only serve as placeholders for the required functionality. Now, how do you implement this? Basically, you implement an interface means that a contract provides the actual implementation of the functions defined in the interface. It basically is the same ditto as what function you've specified in the first smart contract. We can go through that in another example over here. I think it's called interfaces. Right. So here we can see that we defined an interface named payment receiver. We can see the keyword that is used, interface. And there is only one function in this interface, receive payment. Now this receive contract, there is a contract, new contract called receiver contract, and then there is a sender contract. So this receiver contract implements the payment receiver interface. How does it implement this interface? It uses the function over here that is, mentioned in the interface. Because, this function is mentioned in the interface, the sender contract can also take information from the interface. So basically this receiver contract, it interacts with the interface by providing the implementation for received payment, and it tracks the total received amount. You can see the received payment function mentioned over here. And this received amount is updated just as when certain data is changed in the value. So the value is being changed properly, and inside this contract, the value is being changed. But the function can also be used for the sender contract over here. You can see that in the sender contract, it interacts with the interface again through the payment receiver. You can see the payment receiver basically means it can check the value without even, having the receiver contract other details. So there is proper, data transfer only with regards to certain functions, like not all data is being transferred or being used between different smart contracts. This is how you create and implement interfaces between two smart contracts within the same blockchain app. Okay. Does anyone have any questions until now? Because we have gone over one basic aspect of Solidity, but we've gone over events and um, interfaces. Now we can go over to the other part.
Hello, Darshna.
Yeah.
Shall we
Yes,
take a
ma'am.
break? Like, we are planning to do a quiz. So, can we
Yeah,
conduct it
sure.
right now?
Yeah, sure. Yes.
Okay. So, everyone, we'll be providing you a link in the comment box. So, do join the quiz using Mentimeter, and the winner will be given an FT. So, do give the right answer in the least time. Okay. So, let me share the screen.
Sure.
Everyone, do join. Those who are joined, this will be considered as your attendance too. So join quickly so that we can start the session, start the quiz. So, okay, let's start the session then. Choose the right option in the least amount of time. So you'll be given 10 seconds. In which programming language is Ethereum written? Python, Kotlin, Solidity, TCL. Okay, cool. Everyone knows the right answer. Next question. Which technologies does blockchain use? Peer-to-peer networking, asymmetric cryptography, cryptographic hashing, all of the above. Okay. So all of the above was right answer. 4 of them had it right. Which among the following is true with respect to Solidity programming language? Solidity smart contracts can store more data. The file extension of Solidity file is .sl. Solidity uses interpreter to run. Solidity is a statically typed language. So no one got it right. Okay, Solidity is a statically typed language. That is the right answer. Let's move on. In Solidity, which data type is used to represent whole numbers? String, address, bool. 9 of them got it right. Moving on. What is Solidity primarily used for? Web development, writing smart contracts, game development, app development. Is a really, really easy question. I hope everyone got it right. Okay. So the winner is Harikrish. I guess. Yes. Harikrish.
Hari, you can share your
Okay.
wallet address to me.
Hi, hello.
You can find me.
Harikrish, can you share your wallet address?
Hello. Am I audible? Hello.
Yeah, you are.
Do share your wallet address to any one of the group admins of Web3 TPG Kerala. Hello?
Yeah.
Yeah, you are audible.
Yeah, I'll WhatsApp.
Hello?
Hello, hello. I think I have some
Okay.
network issue. I will surely
Yeah, okay,
WhatsApp.
okay. Do WhatsApp it. Okay, yeah, sure. In case you have any doubt, do message one of us because you'll be receiving an NFT. So don't miss it. Okay? Congrats once again.
Okay, thank you. Thank you.
Darshana, you may continue the session.
You guys can see my screen, right? So I think you guys can see my screen. I'll just continue. So, also one thing that I thought I'll just mention now that there was a quiz that happened. So there was this one question where no one got it right, where you guys were like supposed to mark that Solidity is a statically typed language. So what basically statically typed, or what at least I know statically typed basically means is, let's say you are defining a data type, or you're defining a variable in with a particular data type in Solidity, or like any language. You cannot change the data type of the variable in between, like throughout the language. Like once you say there is like int I, you cannot be like, okay, now I can just use I to be a string. You can't do that. So it's defined that I is going to be an integer throughout the code that you're writing. So that basically means that statically typed. So like C++, all of that is statically typed. Whereas dynamically typed, I think it's one of the main things that differ is like there will be extra runtime in trying to check what kind of data type that variable that you have mentioned is. So that I think I thought I just mentioned. Cool. Okay, so until now we have seen events, we have seen error handling, and we have seen what interfaces are and how to create and implement interfaces. And now we will go over inheritance and modifiers in Solidity. So people who have done proper C, programming language classes before, they would know what inheritance basically means. It's the same way here in Solidity as well. So in Solidity, inheritance basically it enables code reuse and modularity in smart contract development. So what it basically means is you can have one set of structure or like a skeleton using which you can create new contracts that have the same properties and functions that are mentioned in the skeleton. So this skeleton or the basic uh, like like the basic skeleton or the background, the backbone of the inheritance stuff, it's called the parent contract. And the new contracts that take in the modifiers or that take in the functions or properties from the parent contract, they are called the child contract. And so this mechanism, it helps in producing a structured approach to design basic different contracts, and it helps in making it all, like proper structured, and basically to write clean code, you use how to, you should know how to use inheritance and contracts and classes well. So what are parent and child contracts? So parent contract is the base contract, the background, the backbone contract that contains the shared functionality, and it serves as the blueprint for child contracts. And it helps in defining the functions, variables, and modifiers that the child contract can inherit. Now, this child contract is the contract that inherits from the parent contract, and it can use, override, or extend the functionality that is provided in the parent contract. So once it uses some function that is already defined in the parent contract, it can also have, a new function that uses the function that we have taken from the parent contract. Now, these child contracts are specialized contracts that build on the foundation that is used on the parent contract, and they are individual. So, like again, I'm giving probably the same example, cars. If you have, let's say, a car, the name, the model type, the payment, the color, how many years, like how old it is or something, that can be the backbone. Now the child contract can have, one or three or even all of the properties that are mentioned in the parent contract. So instead of, mentioning it for each and every card, you can just inherit from the parent contract card. Okay, so I went over what inheritance is. I didn't want to give multiple lines in presentations, but now that you know what inheritance is, like how a child contract inherits from parent contract, you need to know how to modify it. So modifiers are these customized functions in Solidity that are used in conjunction with inheritance to implement these common patterns that are passed on from the parent contract. So by definition, modifiers are defined in the parent contract. Modifiers are defined with specific conditions of check that must be satisfied for a function to execute. So modifiers are reusable pieces of code that help enforce common checks for inheritance to occur. Now, you can use modifiers in different ways. You can use modifiers to modify the different functions that will be inherited from the parent to child contract. And I can probably give an example over here. So this is an example for inheritance and modifiers in general. So in the provided example, we can see contract inheritance between parent contract and child contract. You can see parent contract over here. You can see child contract over here. Now, this parent contract is the base contract that defines an only owner modifier. And then there's also a constructor. And this only owner modifier restricts certain functions to be callable only by the owner of the contract. So you can see over here, you can see the required keyword. You can see that only when the sender is the owner of the contract, the function can be executed. So you have the modifier. So this modifier, basically what it does is you have the function already over here, but this modifier checks, has this, check such that only when the sender is an owner, you can do it. And this constructor basically what it does is like this constructor is just to set the owner as the one who's giving the message. Like once you implement the smart contract, the person who's sending the message, the person who's implementing the smart contract is going to be the owner. And this will only going to be done once whenever the smart contract is being executed. So just to specify who the owner is. Now here in child contract, you can see it inherits from the parent contract using this keyword is. So this is used for inheritance. This child contract is inheriting from the parent contract, and it inherits only the only owner modifier and the do something function. Like any function that write over here. If you have a function do something, this function can be used by the child contract if he or she mentions that over here. You can mention, let's say that you have a function over there and you want the child contract to also have the function that is mentioned in the parent contract, then you can have it in the function over here along with the only owner modifier. Then it will check whether it can it can go through certain statements, and if it allows the statements to be executed, if even if you're not an owner, then it will be done. Otherwise, it'll just probably give another statement where you're like you're not the owner, you cannot do it, etc. So this is an example where we can see the inheritance in play. Now, I think in the starting of the presentation, I would have mentioned how you can interact between different smart contracts. So like one person has really nicely asked what oracles are. Oracles are used to take information from outside the smart contract, outside the blockchain. But here you can also interact information between smart contracts. And this is how you do it using cross-contract calls in Solidity. So by definition, cross-contract calls, they refer to the process of one smart contract and one smart contract invoking the function of another smart contract that is deployed on Ethereum. Now, this also enables the apps and other smart contracts to share data and extend functionality by reusing the existing contracts. Instead of writing every single piece of code and copying it from one smart contract to the other and having multiple lines of code, let's say you just want one function from this smart contract, you just invoke a cross-contract call instead of like you write clean code and you invoke this cross-contract call so that you unnecessarily don't use certain gas fees or extra code in the blockchain. Now, these are generally used in certain cases. They are not generally used everywhere. They are also not necessary to use everywhere. So they allow developers to break down complex systems into modular contracts and each responsible for specific functionality. So let's say you have a very big application where you will require users to access different applications or different functions and different applications for each call. In that case, it is quite unnecessary to write one single, code, and where you have it's unnecessary to write different codes for different users. Instead of that, you can just have different modular contracts where each contract performs one certain function that is necessary. Now, there are places where interactions between contracts are used for transferring tokens. Let's say you want to transfer tokens between two different smart contracts or other data, important data between the users and the smart contracts. Again, here in oracles, you can see external data sources or oracles are probably one type of cross-contract calls. They need not be the only type of oracles. Like oracles, let's say, instead of getting external information from the website or from Google, you use it from getting a smart contract, which already uses another oracle to get from outside. So this is how you do cross-contract calls. And you can also control access by delegating certain functions to specialized access control contracts. We have probably seen it in the previous example that I mentioned, like how it checks whether the user is the owner, and this modifier will help make sure that the function that is, this do something function will be done only if this only owner modifier is this requirement is being satisfied. only if you're the owner, you can do this function, something like that. So you can use the same, access control. You can manage this access control between different Solidity smart contracts using cross-contract calls. Now, there are certain best practices that you need to keep in mind whenever you're implementing cross-contract calls. I haven't given examples to all of these, but I think these are just, you just need to keep these in mind whenever you are making smart contracts. You can Google them, you can Google them anytime, but just know that whenever you're calling functions in external contracts, it's best to practice to define interfaces for these external contracts. These interfaces will, it will also help in error handling because let's say you haven't defined interfaces and then suddenly you have a smart contract, you haven't used interfaces, and you are introducing a new function in the smart contract. You want to, make a new feature. You're introducing a new function. Now you don't want to, make sure that every single set is like access is given or something. So by using an interface, you make sure that everything is seamlessly done. And again, error handling. You have to always handle exceptions or, especially when you're making payments, make sure that insufficient funds or whatever they are mentioned and like make sure to check all loopholes that are possible because sometimes you may access this place or any user might access this place where you don't know how to revert back to that condition. So make sure to go through all loopholes and gas estimation. So whenever you're making cross-contract calls, be mindful of gas cost and make sure that you only transfer certain data that are needed. And if you're making it in the large scale, there are certain tools for gas estimation and re-entrancy protection. So like there is some tool called Estimate Gas, which I personally have not used. So you can probably use these new tools that are there in the market right now to estimate the gas that will be, used whenever you're making cross contract calls, especially when you're dealing with uh, big, um, big DApp or a big blockchain network. You will definitely need to see gas estimation because these type of cross contract calls will be happening multiple times in a minute or a second, depending on what application you make. Now, there is also a re-entrancy protection where sometimes there will be malicious users that are trying to access your smart contracts. You can probably also seek help from external tools like re-entrancy guard pattern and these methods. Now, managing state changes and checking data consistency in cross-contract calls is also another aspect that you need to keep in mind. Now, whenever you're making multiple calls to external contracts, ensure that state changes are atomic. Now, what I mean by atomic is either all changes succeed or none do. Whenever you make multiple calls, you can have multiple calls and you can have one only result, which depends on these multiple calls. Make sure that the state is changing efficiently. Let's say you have 3 calls to make in an app, and then in the end, only when all three of these are, all three are successfully done, you can go to the last one, which is basically the payment gateway or something. Now you don't want the state of the variable, let's say instead of it being false, let's say if you don't want the payment to happen, instead of it being false, it happens true because one of these three multiple calls happened. Now you don't want the payment to happen in this sort of messed up situation. So you need to make sure that the state of the variable that you're using whenever you're making cross contract calls is changing properly. And event logging. We've already mentioned event logging where you're going to emit these events whenever there is state change. You are going to mention, like log these information and so that these are stored in the blockchain. Even if, there is some problem that has happened or something, you can go back. You cannot go back in time, but you can go back into the data chain, like the data block that is there in the blockchain, and you can track the state changes that have happened, and you can see where exactly the problem has been done. So these type of problems can be solved using, proper event logging. And this is something, again, you need to know whenever you're making a large scale blockchain application. You need to thoroughly test, and before deploying it in the real Ethereum blockchain or probably any other blockchain if you're using, you need to check that uh, these interactions are happening the way you want to in, let's say, a remix IDE or some other place where you are not using real money or real ETH. So there are multiple simulation tools that are also there in the market. Yes, is anyone talking? Oh, okay. Actually, talking about testing, I think you might have heard about this. There are multiple testing platforms like Truffle, there is Hardhat, there is Remix ID itself. So before you deploy it in the blockchain, right, make sure you test it appropriately. So here, I think I can give you one small example involving token transfer. So here, you can see this ERC20 token. This example will be used in the next part that I will also mention now. But here, there is an ERC20 token interface, and it represents the functions of an ERC20 token contract. So these functions, they are used over here. So you can see the token address is mentioned over here. There's a token transfer. These transfer and balance off is used inside this transfer tokens function. So this transfer tokens function allows the contract owner to transfer tokens to a specified recipient by calling the transfer function of the ERC20 token contract. So because of this interface, we are able to only get certain functions that we need using this required method. And we are also able to check whether the required recipient is the recipient that is needed. Like, you need to check if the recipient address matches or something, and if it matches, you can go on to emit the tokens transferred, and you like this event happens. Otherwise, you get this error message saying token transfer failed. So you can see how interfaces are used on this function, and how you are basically using different smart contracts you're making a cross contract call. So you can see how you are using the cross contract call using an interface outside the smart contract. So this is just an example to mention cross contract calls. Now coming to the last topic of the presentation, we will go over call data and Solidity. Now, what is call data? You probably won't be hearing it a lot. Like I mentioned, these are intermediate topics. These are generally used whenever you are coding a full-fledged, like a proper blockchain application where multiple users are, using it in real life, like over every single second or minute. So in call data, it's a special data location we've already seen. It's used for function arguments in external function calls. It represents the data that is sent along with the transaction when you invoke a function from an external source. So we have seen that this call data does not, you cannot modify call data. We have already seen that we can only like call this call data, and you can only get certain information. You cannot modify it. Now, call data is a special data location. We have already seen it's immutable data, which means you cannot change the data. There are minimal gas costs, and you cannot change the state. You cannot change anything or modify anything that is already there. Now, when are these used? And why do we use them? We've already seen we do not want extra gas costs. We do not want the app to incur extra costs in any way. So these are generally used whenever you want ERC20 token transfers. So let's say you want to transfer only the ERC20 token to the, you do not want anything else. So ERC20 token is some token that you get whenever you are, like, let's say you have done a backend where you're trying to authenticate or authorize a user. So to authorize users, there will be certain tokens that are associated with each user. So you need to transfer these tokens to check whether these users are actually the users that are mentioned. So to authenticate and authorize these users, these tokens are used. This is what an ERC20 token is. And since because it's a specific case, you don't need to change any data. You're not going to change the token. It's not a variable. You're only going to retrieve the token. You're going to check if the user is the one that you need to be. So you can use call data over here. And you can use to query contract data because you're not going to change any. You only need to pass input parameters that you need to get information from and or request specific actions. And again, in oracles, you're only going to get information. You're going to fetch external data and return it to the contract. You're not going to, change information from outside that is coming in. And there is also external contract inheritance. Sometimes you just need the information. Or in all these places, you just use call data. And because it does not allow for state changes, there is minimal gas cost. These are a very good clean code examples of what you need to have in your app. This is similar to the function. This is similar to the previous smart contract code we have, the ERC20 token one. Here we can see that we are defining an ERC20 token trans interface, same as over here. And here we can only have one function. We are having one function called transfer. And there are multiple functions inside this smart contract. You have this function called transfer tokens. And what it basically does is it uses call data to specify the recipient address and the amount of tokens to transfer. This ERC20 token equals ERC20 token address. So it checks whether this thing is satisfied. And once this transfer is satisfied, if it is not satisfied, it says token transfer failed. And if it satisfies, the transfer event is empty. The tokens are being transferred based on the sender, recipient, and the amount, the variables that you mentioned before. So you use a different callback. You're not going to change the token value over here. You're only going to get it from the interface. You're only going to check whether the data is same. So callbacks are very important. You can even for error handling, let's say you want to check certain values, you're not going to change the values that you're going to get. So that time you can just use call data to get those types of variables, and that's it. So in conclusion, I think I'll just go over what I have talked about today. We went over intermediate solidity, like you're writing solidity properly, you're writing full-fledged smart contracts where multiple users are logging in, working with data, you're doing real-time payments and all. So we have gone over how to optimize data storage, minimize gas costs using different data locations. We have gone over creating events and, like logging these events, how to emit these events for enhanced transparency and proper auditing. We have dealt with robust error handling and other errors how to make sure there are no loopholes, and how to interoperability, how to implement interoperability using interfaces between smart contracts. And we've also gone over inheritance, where you can write smart code where you are, using inheritance to inherit information from parent to child smart contract. And then we are using calls between between different smart contracts and using these calls properly. And we are having the delegate call and call functionality. It's basically the call data that we just mentioned. So I've reached the end of my presentation. I know this has been a lot of, proper technology, like a lot of terms that I just mentioned. So if you guys have any doubts, or I think this will provide like a decent structure or like a background for you guys to work on. You need not use only the information here. You now know what to expect whenever you're writing smart contract. Now you can, access these resources, which I'm sure will be provided by TPG as well. You can ask in the groups. So if there are any doubts right now, you can ask them. Or Harsha, you can take over from now, I think.
Hi. So if there are any doubts, do put it in the chat box, or you can ask right here. Okay, we'll wait for a few minutes. Okay. So, Darshana, that was a insightful session. Thank you so much. And thank you, participants, for joining for today's session. And a special congrats to Hari Krishna for winning the NFT. See you all in the next session. So, bye. Good night. Thank you.
Thank you, Harsha.
Bye. Thank you.
Hello. Hello, Harsha.
Yeah, hello.
Hey, so like someone DM'd me in this thing itself, Zoom meeting itself, telling me to share the PPT. I sent the link over here too. Can you like share it to the people who attended the call today?
Which link? I didn't get you.
The PPT link. I sent it in the chat here. I can also send it in WhatsApp. Can you share it to the people who have joined the call today?
Yeah, sure, sure.
Okay, thank you.
Yeah, so if anybody wants, then you can DM the admins in the group.
Okay. Someone called 4029 Jasmine asked. So just
Yeah,
share it in the group or something.
yeah, Jasmine, you can DM Harsha or me, Ashwin, in the
Okay.
admin.
Thank you.
Thank you. Good night.